All right, so by now, everyone should know what an inequality is, okay? Inequality is basically a comparison of two numbers showing that one is greater than or less than or simply just not equal to another value, okay? So inequality symbols that you should know: less than, greater than, less than or equal to, and finally, greater than or equal to, okay? These are the four inequality symbols that everybody should know by now. So what are we going to do with this? Well, today we're going to learn about what these symbols mean. When you read an inequality, you're always reading it as whatever the first number is. So let's say 3 is less than 4. True statement. Or 5 is greater than 2. And 6 is less than or equal to 6. That's true. And then 7 is greater than or equal to 1. That's also true. So these are very straightforward. Now, when this gets a little bit more ambiguous, it's actually going to look like this. This statement says that x is greater than 1. So when I'm looking at an inequality that has a variable in it, I always need to look at what can x be, okay? Well, if I'm thinking about this, I'm looking at possibilities for x. So x can be 2 because 2 is greater than 1. X can be 3 because 3 is greater than 1. If I want to show you all of the possible ways or all of the possible values of x, I can't just list them because that list would go on infinitely. Okay, think about all the numbers greater than 1. There's an infinite amount of numbers, so there's an infinite amount of values that x can be. The way that we show what values x can be is by graphing it on a number line. So if I create a number line, I should be able to show you all the possible values of x. I'm going to teach you right now how to do that. In order to do so, we need to figure out how we graph according to what inequality symbol we have. So let's think about that. We'll come back to this page, okay? First thing, if x is less than a number, okay? This means that x cannot be that number. For example, if I go back, here it said x is greater than 1. Can x be 1? No. Well, here if x is less than a number, x cannot be that number. So if it was x is less than 2, can x be 2? No. So in order to graph this, and I'll put that example here, let's say x is less than 2. So to graph this, what I have to do is I'm going to take whatever this number is on my number line, and I'm going to put a circle over it, and I'm going to leave that circle unfilled. Okay, I'm going to call that an open circle. The reason why we leave it unfilled is to show that we're not including that number. Now, if x is less than, and I'm thinking about a number line, right? I'm thinking about a number line. If I'm looking at a number line, which direction am I going to go to show less? Am I going to go to the left or am I going to go to the right? Less is always to the left. Okay? So in this example of x is less than 2, if 0 is here, let's say 1 is here, 2 is here, 3 is here. If I wanted to graph this, I would put an open circle over the 2 on my number line. And remember, it has to go on the line. So I'm going to put the open circle right here to show that x cannot be 2. And since it has to be less, all the numbers less than 2 are all to the left of 2, right? 1 is less, 0 is less, -1, -2, -3, so on and so forth. So I'm going to draw this line. And because I put an arrow at the end, that means that this is going to go on forever. Okay? Every number to the left of 2 is included. Now, some of you might be asking, well, why didn't I just put the circle on 1? Let's think about that. Why did I not put the circle on 1? Well, let's just graph out 0, 1, 2. If I put the circle on 1, A, that means that I'm not including 1. B, what about all these numbers? What would go in between? Numbers like 1.1, 1.2, 1.5, 1.99. These are all numbers that are still less than 2. When I'm thinking of what numbers are less than 2, I'm not just thinking about whole numbers. Okay, I'm not just thinking about integers. I'm thinking about every single possible number. Well, all of these are still numbers. Okay? So that's why I don't put it on the 1. That's why this portion between the 1 and the 2 is so crucial, because again, there's an infinite amount of decimals between 1 and 2. So your answer would be completely wrong if you wrote it this way, because you literally left out an infinite amount of solutions. That's a lot of solutions. So let's go on to the next example. So we just did x is less than a number.